Hi, this is Juan Carlos. My Panther ID is 6229898. This is Lab 8.
And I'm Anthony Diaz, Panther ID 2890516. Now this activity was divided into 3 different circuits, and this is the model for the first circuit here. So we have input of voltage, which is going to resistor C. Resistor C is connected to resistor 1, which is and resistor C is also connected to the positive side of the BJT transistor. Resistor 1 is connected to resistor 2, connecting to the front side of the transistor. And resistor 2, as well as resistor E coming out of the negative side of the transistor, is both connected to ground. Now for this experiment, we were supposed to discover what were the values of the 3 resistors and the value of the voltage input whenever they were with the given equations that were for the lab. Now, first, the way we did it, we first did it by calculations. Then we simulated those calculations on the multi-sim, and if the values came out correct, we built a circuit with the exact replications of the sim, and this is what we have here, and everything seemed to have been turned out fine. So for the first calculations, you can see that we got the resistors for values R1 and RC at 1K and 2K ohms each. The values for the third resistor at 1.05K, and the values for the final one at 1.4K, and the VCC coming out at 10 volts. For part B, we had to measure the value of resistor 2, and first we did it by calculations, which gave us at 2.8 volts, and once again that came out as the multisim as the correct voltage.
Oh, same one. Sorry.
And then the final part is what were to happen if we let RC equal 0 ohms and let RC equals 100 ohms, and then we were supposed to measure the current and the transistor. So first for 0 ohms, we first did it by hand, and we got a calculation of 2 multiamps. And then with 100 ohms, we got a calculation of 6.1 volts.
Do we have access for it?
And that's exactly what we got on the sim, and then when we measured it by the circuit, that's exactly what we got too.
So moving on to part 2, where we're designing this circuit, as you can see here, and it was the same process. We needed to find out all the values of the resistors and the capacitors. We also did it by hand first to try to satisfy all the conditions. We find out that the resistor 1 is 2K. Okay, I apologize, I was mistaken with something else. This is actually the circuit. So after doing all the circuit analysis and finding out all the resistor values, we got to the point where we found that the resistor 4 was 515 kilo ohms, the resistor 3 is 5.5 kilo ohms, resistor 5 is 10 kilo ohms, and the resistor 6 is 495 kilo ohms. Those resistance values are found to be able to satisfy all the conditions for the current through here. The current through here, I think it's called IB, is very, very, very small that we could actually disconnect this and it wouldn't make any difference on the circuit. Alright, so moving to part 3, let me show you guys the configuration for part B. Okay, yeah. So this is the circuit for the second circuit. Here we can see all the transistor with the two resistors coming out from the legs, and then here the resistor with the capacitor. This one goes to the ground, and this one going ground as well, and this one going to the power supply. Moving on to the last part.
That was it.
Moving on to the last part. This is the setup for the last part, for the part 3. It was the same thing. We needed to find the value of the resistors. So yeah, the goal of this third party was the same thing as for the first one and the second one was to find the value of the resistors and the value of the capacitor here. So here we can see the configuration is the same circuit as the second one, but we include this part right here with a capacitor going to the one of the legs with the transistor, and the capacitor, this one doesn't exist anymore, so we just take it out. Oops. And this wire here goes to the AC source. We did it by hand and did it on the Simulink, and we found out that the results are the same. All right, this is Lab 8. Thank you.